So when we look at Spring Cloud Gateway for Kubernetes, what is it? So we talked about that consumer API experience. You're coming into one place, the Spring Cloud Gateway that's in front, which can be HA enabled with multiple instances and handle the volume of traffic that you want. It can also be optimized at the JVM level for performance. And even within the Kubernetes cluster, adding different requests to the cluster for memory and CPU, et cetera. On top of that, it adds some commercial features such as single sign-on support. So we automatically allow you to configure an OpenID Connect provider. You might be using Okta or Auth0 or one of the ones that you have on your enterprise on-premise deployments. And on top of that, you can also use it in front of any type of application. It's polyglot support. There's no need for you to know Spring and Java. It's just a configuration to make your application expose its APIs on the gateway. And I'll show you that in just a moment. On top of that, we've seen a lot of folks using an external service. So you might have a heritage application running on a VM somewhere, and you want to front it with a Spring Cloud Gateway for Kubernetes gateway instance. And what you could do is create an external service on the cluster, do all of the network kind of policies that you want to around that connectivity from the cluster to that heritage application. And you can then route traffic through the gateway to that application running off platform. So how do you define these different custom resources for a Spring Cloud Gateway operator? Well, one of them is the gateway itself. So a gateway is an instance. It has an HA configuration. It has some JVM properties that you can kind of work with in order to optimize its performance for the particular use case you have for this gateway instance. And typically in production, you'll have like an application operator, DevOps group, or an operations group that's really defining this gateway instance using a YAML file. They have a URL that they want it to be served at. They might be setting that up in ingress and in global DNS, whatever may be. But in the end, they're going to kubectl apply this particular custom resource definition into a cluster. Now, there's the other part of this, which is a totally different custom resource, and it's called the API route config. And the API route config is something that lives with the code. So I may have many different application services all behind a single gateway instance. And that API route config for my service, as you notice here, we actually have a spec service name defined, and it's going to say the service animal rescue backend, a Kubernetes service name, is going to be associated with this route configuration file. And then below it are all the routes that I'm going to expose from that service and the different filters and predicates that I'm going to apply. And we'll talk about filters and predicates in just a little bit. But the idea here is that from a developer friendliness point of view, this lives with the code and is on the same life cycle with my code, can be put into automation like continuous integration and continuous delivery models. All through your code base, so in the same Git repo as your code. And then there's a third piece. Okay, now you have a route definition that's defined and just says this is the service that it's for. We have a gateway over here that's defined. And like I said, what we can do now is we can take the route configuration and say map it onto this particular gateway. And so you could do any number of route configuration resources and map them to a single gateway. So it's a very simple file. During this process, it's just going to make sure that the gateway gets dynamically updated. Remember that the gateway itself never goes down when you do this operation, but as it processes the information from that route config, it'll update all of its routes to show the new information, the new routes that are available for the users, the consumer API developers to use.